Okay, so we were talking about our Mendeleev's periodic table. We have seen its advantages over the previous Newland's law of octaves and Doberiner's triads and stuff. Now, but this Mendeleev's periodic table, certainly, as everything, has its disadvantages. It had disadvantages, that is why the new periodic table has come to overcome these disadvantages. Now, the first disadvantage was the position of hydrogen. Now, as we have seen that the position of hydrogen was clubbed with the alkali metals, or what you call hydrogen, lithium, sodium, potassium, and it's perfectly okay. But hydrogen has similar properties with lithium, sodium, potassium, like hydrogen forms HCl, H2O, and potassium also forms NaCl, Na2O and stuff. But hydrogen also has properties similar to halogens. What are halogens? They are fluorine, chlorine, bromine, iodine. These are all halogens. Now, how did these hydrogen have properties similar to halogens? See, all these gases are in the form of F2. First of all, they are gases, and hydrogen is also gas. While all the other, lithium, sodium, potassium, they are all solids at room temperature. So the first similarity was that hydrogen is gaseous at room temperature, like the halogens. So the first similarity of hydrogen was gaseous at room temperature, like halogens. Now the second thing was that hydrogen also existed as a diatomic gas. Like we have F2, Cl2, Br2. That is just like that. We also have H2. And why is that? Because we get some space here. Why was it? Because hydrogen has one electron represented by this cross. So to make a stable shell, it needs to get another electron, or it needs to give away this electron and remain just a proton. So it can share this electron with another atom, isn't it? So this also has 2, this also has 2. Both hydrogens are happy because they are sharing. So, and like chlorine, fluorine, bromine, they also follow the same thing. Chlorine also has 7 electrons. 3, 4, 5, 6, 7. This also has 7 electrons. This also shares 1 electron. So both have 8. This also has 8. This also has 8, since 1 electron is shared from both the chlorines. So that is why hydrogen in need of an electron goes to form a diatomic molecule of hydrogen, which is H2, and which is similar to the reason why Cl2, F2 are formed, because they are in need of 1 electron. So the second thing is that it exists as H2. And the third is that it has properties similar to this. Like you have NaCl, you might not have heard of this compound, but you also have NaH. A very odd type of compound, you might be thinking, but it perfectly exists because hydrogen has one electron, so it can give away this electron as it does in HCl and stuff, or in HCl it's just sharing again. So it can give away this electron and become H plus, but it can take one electron and become H minus, and it really does become H minus. And in NaH the same thing happens. Since here it is Na plus and Cl minus, here it's nothing but Na plus and H minus, because H minus is stable, it has 2 electrons. So Na plus and H minus is perfectly possible. So Na plus and H minus, they can form NaH, and similarly we have KH and stuff like KCl and this KBr and stuff. So the third thing is that it forms compounds with alkali metals. Alkali metals is the common word. It's just used for lithium, sodium, potassium. These are nothing but alkali metals. Or let me give you some more common names. This group is known as alkali metals, and that beryllium group, beryllium, calcium, then what do you have in this, magnesium, they are not in order, I'm just writing like that. These are known as alkaline earth metals. And then of course you have fluorine, chlorine, bromine. These are halogens. These three are the most important group names because you commonly call this group as alkali metals, this group as alkaline earth metals, and this group as halogens. So if anyone asks you, I mean, you can get a question, it's not very probable, but you can get a question like in which this word is mentioned, so you need to know what this group of metals are. So why is hydrogen similar to the halogens? Because it's gaseous at room temperature, it exists as a diatomic molecule H2, and it forms compounds with alkali metals just like halogens. So coming to the disadvantage, it has properties similar to halogens. So how can you say with confirmation that it exists with it can be put into the group with the alkali metals? You cannot say you cannot just put it into the group with alkali metals. Then you're neglecting the fact that it has properties similar to halogens. So that is why that was one disadvantage. The second disadvantage, so the first was the position of hydrogen. The second disadvantage was the problem of isotopes. Now what are isotopes? Isotopes are different forms of the same element which have same atomic number but different mass number. Mass number as in atomic mass.